The 6-minute liquidity evaporation. On April 18, 2026, a single logic error in a cross-chain bridge evaporated $177 million of kelp DAO liquidity in under 6 minutes. While traditional message passing protocols collapsed under the weight of invalid state transitions, math-based aggregation layers did not blink. This was not a failure of code, it was a failure of the bridge architecture itself. We are now entering the era of the invisible blockchain, where the concept of moving assets between chains is being engineered out of existence. And the underlying engineering reveals exactly why most bridges are structural liabilities. The vulnerability of social consensus. Traditional bridges rely on a multi-sig or a small set of validators to witness a transaction on chain A and then mint a representation on chain B. This creates a massive security assumption where users trust a middleman to report the truth. In the kelp DAO event, the exploit targeted the latency window between the source chain finality and the destination chain minting. By the time the human-monitored validators realized the state was inconsistent, the bad debt was already locked into the DeFi ecosystem. Chain abstraction attempts to solve this by removing the middleman entirely. The mechanics of this shift from social trust to mathematical proof are found in the aggregation layer. How math replaces multi-sigs. Chain abstraction shifts the security model from social consensus to cryptographic proof. Protocol designs like Polygon's AG layer or NEAR's chain signatures use zero-knowledge proofs to unify liquidity without requiring a third-party bridge. Think of it as the difference between a notary signing a paper and a calculator verifying an equation. Instead of sending a message saying an asset moved, the protocol provides a mathematical proof that the state transition is valid across the entire network of chains simultaneously. This treats multiple independent blockchains as if they were a single logical entity. This design choice effectively eliminated the latency window hackers exploited 10 days ago, but the technical trade-offs are significant. The hidden costs of Rigor. This shift to mathematical certainty is not free. Implementing ZK aggregation requires intense computational overhead and complex proving circuits that are significantly harder to audit than standard smart contracts. A bug in a ZK circuit could be catastrophic and much harder to detect in real time than a simple multi-sig compromise. However, the data from April 18th shows a clear divergence in outcomes. Networks utilizing the AG layer automatically rejected the malicious kelp DAO proofs because the state transition simply did not compute. Traditional bridges executed the transactions because the validator's signatures appeared valid on the surface. This creates a fundamental divide in protocol reliability. The connecting thread. The $177 million kelp DAO exploit marks the definitive end of the bridge-centric era and the birth of unified state execution. By moving security from the witness layer to the math layer, as seen in the resilience of ZK aggregation, the industry is effectively making the underlying blockchain invisible to the protocol logic. The real implication is that we are moving away from fragmented liquidity pools and toward a global state where the specific chain hosting an asset is an implementation detail rather than a security risk. For developers and analysts, this means the competitive advantage is no longer about attracting bridge volume, but about optimizing for proof generation speed and reducing the cost of mathematical verification. This change turns every isolated rollup into a component of a single, massive superchain. Watch for the integration of chain signatures into legacy layer 1s throughout the second half of 2026 as the primary indicator that the era of manual bridging has concluded. Subscribe for more